So the first skill you guys need to be able to do is pseudocode and program code. So I'm going to do PC for program code. Create a hash table. Now in this scenario, it's giving us that we're going to have a 1D array. So each index will represent a 1D array. And we're going to have from 0 to 199. And that we want to set each record to 0 for customer ID. So I'm going to do CID. Right. Now, my advice is to practice the pseudocode and Python equivalent to this. Today I'm just going to focus on pseudocode, and I want to see if you guys can do the Python yourself. So we've got a procedure set up, but we now need to declare our array. Now in Python you don't need to declare, but for pseudocode we will do. So declare customer, because it's called customer. It's going to be an array, and the range is going to be 0, 199, and then we need to put the data type, in this case of customer record. This customer record contains both the customer ID, what's going on? Oops, customer ID and the data. So what we've done now is we've created our empty boxes. We're getting to 199 from 0, but we've got nothing in it. What we need to do is put 0 in for customer ID. So to do this, we need a loop. This loop will access each index position, and each time it goes to an index position, it's going to put 0 in it for the customer ID. Sorry Martina, I've used a different color. Okay, so we're going to do for x, or it could be for I, whatever, in range 0 to 199. Inside our for loop, we're going to have customer. So we're talking about this array, so customer. X, so whatever index position the for loop is in, so it's going to start on 0, so we're going to start here. And in there, we want to put, for customer ID, assign it the value of 0. End for. Ba-bam. So we've got our for loop, and for each time we iterate in our for loop, it's going to start on 0. It'll then move to position 1. Oops. So x will become 1 quite naturally, which means for our array, this is also going to be 1, and inside 1 we're going to put customer ID 0. It's going to iterate again. This is going to become 2. That's going to become 2. And we're going to put inside it 0. And it'll keep going until 199. And there we have our hash table. Let's have a look at part 2. So the next part of the question is inserting a new record, i.e. for customer, into our hash table. So we've got a hashing function where the hash function exists already, so we don't need to do the calculation of the mod length. It's already done for us. It takes a parameter of the customer ID and returns an integer 0 to 199. The procedure insert record will take the parameter the customer record to be inserted into the hash table. The procedure makes use of the function hash. It's done for us. Collisions will be managed using open hashing, i.e. using linear probing, the next available location. So we're going to start with table full equals false. So I'm going to do tf equals false. So table full equals false. It's then going to generate the hash value, and to do that we want to use this inbuilt function of hash. And what is it that we want to hash? We want to hash the new customer ID. So that'll give us a hash value for this customer ID. We need to put the record first, and then we need to say the field in the record. We then put whatever value this is and place it into the pointer. So let's imagine it gives us the number, I don't know, 70. Index is going to become 70. Pointer is going to become 70. Now what we want to do is find a free space in our table. So what we're going to do is we're going to do whilst the customer pointer dot customer ID is greater than 0. So it's going to go to customer. So this is customer array. It's going to go to position 70. And it's going to check to see if whatever's inside it is greater than 0. If it's greater than 0, that means we've got something inside it already. That means we can't place our new customer ID in there. If it's 0, then we will be able to. So whilst it's bigger than 0, we then want to do pointer equals pointer plus 1. So if there's something in it, let's imagine we've already got the number 70 in it. We're then going to go to the next available space. Pretty simple so far. If, though, when we get to 199, we want to say, uh-oh, we're full, and start again at 0 to reset it. So, if our pointer, this is by the way still inside our loop, just to make note of that. If our pointer is greater than 199, so if we've incremented this pointer up to 199, so we check this, we check this, we check it, kept going, it's full, it's full, it's full, it's full, it's full. Pointer's going to be reset to 0. Boom. Nice and easy. Now what we want to do is check this and compare it with the original index. So the original index was 70. So what's going to happen is this. Let's imagine that 70 is full, 71, 2, 3, 4, everything's full up to 199. So I'm going to go back to 0 and it's going to check these. When it gets to 70 again, we then know the table is full. So if our pointer equals the index, then table is full. This bit is going to be saying what would happen if the table isn't full, because basically this bit is all about checking if there's a space. Now we want to put something in that space. So if not table full, that's another way of saying if table full is false. Then customer pointer, will equal new customer. So we're going to be taking the whole record. That's a customer ID. And I believe, what else was in that record? Help me out here, help me out, help me out, help me out. I think it was data. we're going to put both these things into the current position. So that's what we're saying. We're putting the new customer, our record, into customer pointer, wherever the pointer is. So the table's not full. We've ended the loop. Therefore, what we're doing now is allocating this into this array. So we're going to be putting the ID and the data into there. Otherwise, so if the table's not full, we're putting new customer into customer pointer. Otherwise, we get this error message if the table is full. It's as simple as that. So really, what we're looking at right now is the following. We've got finding the element by doing our hash. We've then got this loop. This loop will keep looping until the pointer position for customer ID is greater than 0. It's going to keep going. So basically, it's literally going to stop when it's going to be at 0. We then we increment by 1 our pointer. We do this bit of code. If a pointer is greater than 199, then we reset this to be 0. We then check if a pointer equals the index, then our table is full. Once we break the loop, if this never becomes true, then our table's not full. Therefore, we're going to place our new customer in whatever pointer we left off. Output error if table is full. So we've got a hash generating a number. We then do a loop. This is going to loop until this is greater than 0. Pointer equals +1. Pointer, so it's going to increment each time to find a position. If a pointer is greater than 199, it's going to go back to 0 again. We're going to check if we're back to the original index position. If we are, great. If we're not, then it's going to keep going. If we are back at our original position, then it's going to say table is full. We will stop based upon if we find a free space or we get back to our index position. If the table is not full, then we're going to place our record inside whatever pointer we were on whilst we break the loop. Otherwise, we're going to have an error. You need to be able to understand the logic of this and the steps. So my advice is break this down into different parts. So we've got step 1. Let me do this on a 1 second. Yo, go away, star. I don't care about you. Okay, that wasn't what I wanted, but let's do fill. There we go. So, step 1, when we're inserting hash calculation, it might be done for you, or you might be expected to do it yourself using the mod. That is step 1. Step 2, after we've done a hash calculation, we want to find free space in table. Step 3, what we want to be doing is compare value pointer with index. And step 4, insert or assign record to array or error message. So we're checking for this error message